Hey guys, it's Sam with Sid back with another video, and today I'll be going over optimization. So this is applied minimum and maximum problems. So let's say you're given, this is one of my favorite topics actually. Let's say you're given like a box with a square base, so like a cube pretty much. So you have cube, cube, and let's say it has an open top. Now, let's say what dimensions it asks. So what are the dimensions? You have x, and it's x all around, by the way. So it's x here, and then you have a certain height, okay? So it's not a cube. It has a square base, but it has any height, okay? So it can be any height, and any x, really, too. What dimensions? This is actually used in the real world, too. What dimensions will produce a box with maximum volume? Let's say it wants to create dimensions that will maximize the volume. Any pair, a pair that will maximize the volume. Now, to do this maximum, this is how you think of it. You're gonna deal with finding a max or a min, taking a derivative, setting it equal to 0, right? Now, so the volume with the square base, the volume is actually gonna be x times x times x, so it's x squared h, right? And the surface area you can use too. You have to use two different equations and try to relate them, basically. Surface area is the area of the base plus the area of all four sides. So it's pretty much going to be, let's say they give you the surface area being 100, because they have to give you something, right? And also, then there's endless answers for this. You can have a maximum x and a maximum h, and you can have a volume that's max. But let's say the surface area had to be 108 square feet. So with a box, with an open, not a box, like a box with a square base, with any x and any x distance, right, and any h height distance, with an open box, right, it has to have a square feet of 108. You don't want to waste more than 108 square foot making the surface area for it, right? What dimensions, given that the square surface area has to be 108 square feet, will produce a box with maximum volume? Now that's a question that deals with optimization. We have the volume here. We have the surface area here. The surface area is equal to, well, 108. We have another equation. 108 equals x squared plus 4xh. Okay? And pretty much what you can do here now, I won't actually do the solving out for it, but you can solve for h using here, right? So you're with something relating to x, right? But you can solve for h, right? In fact, I'll do that. H, actually, if you solve this out, you minus x squared divided by 4x, 108 minus x squared over 4x. You can actually plug that in here, because this is the height in response to x. So you have v equals x squared times 108 minus x squared over 4x. And you can take, well, you're trying to maximize this function. You can do dv. You can find the derivative, and you can really set it equal to 0 to get the max value here. You can find the max x, then plug that in here to get the h, and then you have the dimensions. So you can do this with really anything. So that's pretty much how you do it, optimization. And there are different applications to this. You can do minimum distance if you have like a downward graph of some sort, and you have, let's say, the point, and you have these 2 points. What is the minimum distance d that's closest to this point? Is it this? Like, so what is this distance? You can use the distance formula equation, and you can use the derivative, f prime of x. You can find you have the function as one equation, you have the distance as one equation, the distance formula, and then you can find the derivative by relating those two. You can do minimum area. If you have a rectangular paper and the margins, you have like margins 1 inch here, they have to be there, right? Margins of 1 and then 1.5 inches here, right? And they say, what is the minimum area that you can get for the page? And you can also do minimum length. You can do if you have like a 4 feet of wire, you can find, and you're trying to like form a square and a circle. how much of the wire should be used for the square and how much should be used for the circle to enclose the maximum total area, right? To get the maximum area from a square and a circle, you're going to have to use areas of squares and circles and derivatives and really to figure that out. So yeah, that's pretty much it for the optimization topic. You just have to go out and do questions relating to optimization. Like in the beginning, I showed you very simple example with the box. I related the volume equation with the surface area equation and figured out the derivative. And well, you figure out the derivative, set equal to 0 to get the max, and that will give you the max x, which you can use to get the max h. And that's pretty much it. You just use equations that are kind of related to each other, and in some way with a variable relating them, take the derivative, find the max or min, whichever case you're looking for. And yeah, that's pretty much optimization. Thank you for watching. I hope this helped you. See ya.